Hello, welcome to another video. This is an integration problem with two functions multiplying each other, so it is as if you need a product rule for integration. And remember, when you have this, it's either you think of u substitution or integration by parts. And obviously, the derivative of one is not the other, so u substitution is not going to work. What's going to work is integration by parts. And if you use integration by parts, you want to rank depending on what you will choose to be your u and what will be your dv using ranking, which is LIATE, which means you start first with logarithmic functions, and then the I is for inverse trig functions, and the next one is algebraic functions, but there's none here. The next one will be trig and exponential. Well, you got trig, you got exponential, so the trig will be differentiated, the exponential function will be integrated. And that's what I'm going to do. And I'm not going to do the bunch of writings. I'm just going to use the table because I want you to do it the most efficient way. The most efficient way that I know of, unless your professor says don't do it, use the table. So the first thing I'm going to do is say that this expression here can be written as, I'm going to pull this 2 out and say this is 2i. Okay, so that my I is equal to the integral of e to the 5x cosine of 2x dx. So as you can see, I've completely ignored the 2 because the 2 does not do me any good. It just makes things more complicated. So based on that, we're going to begin. We make the table. So for the table, this is all you have to do. Because you're dealing with a trig function, you know that you're going to come back to cosine. See, if you differentiate cosine, you get sine. If you differentiate one more time, you come back to cosine, and that's it. So once you say cosine and you're doing integration by parts, whether it's what you're differentiating or integrating, you will come back to it eventually, depending on what the other function is. So here, based on the Liate ranking, what I'm going to do is I'm going to say I'm going to differentiate this, I'm going to integrate this. Well, what I'm going to integrate is e to the 5x, and what I'm going to differentiate is cosine of 2x. But remember that for this, you have to put your signs plus, minus, plus. I'm only going to do this 3 times because I know cosine is coming back. So now, let's do the differentiation. If I differentiate cosine 2x, I'm going to get minus 2 sine 2x. If I differentiate this one more time, I'm going to get minus 4 cosine 2x. And I am done. If I integrate this, I'm going to get 1 over 5 e to the 5x. If I integrate one more time, I get 1 over 25 e to the 5x. And that's it. So the next thing you want to do is just write out your answer. So I know by virtue of what I've done that if I go in this direction, my integral, which is this expression I, will be equal to this product, that's 1 over 5 e to the 5x cosine 2x. I take the next one, but I have to take care of these signs. Minus times minus is plus. So that's going to be plus 2 times 1 over 25. So that's going to be plus 2 over 25. Maybe I should write it here. This space is not sufficient. So let's write it here. So I know that I is equal to, we do it again, that's 1 over 5 e to the 5x cosine 2x. And then the next one is going to be, this is plus 2 over 25, plus 2 over 25. And what's left? You got e to the 5x multiplied by sine 2x. Okay, and there's one more. And then when you get to the third one, you're not going down, you go across this way. But let's deal with the constants first. This is plus minus, that's minus 4 over 25. So that's going to be minus 4 over 25. But because you're going horizontally, you have to integrate. Okay? And you integrate e to the 5x cosine 2x. E to the 5x cosine 2x dx. So now we know that this is the same I that we started with. So we can replace this expression with I. We just need to write I there. So this is this I here, and we got 4 over 25 i's here. So we can move this over here so that this becomes 4 over 25i plus the original I we have here. And that's going to be equal to 1 over 5 e to the 5x. I think e to the 5x is even common to both of these expressions. So I can, you know what? I'm going to leave it. X cosine 2x plus 2 over 25 e to the 5x sine 2x. Well, based on what we have, if you add this to this, this is going to be 29 over 25i. Okay? So let's say we have 1 over, let's take out the 25 and the 2 over 25. I take out 2 over 25. What I have on the inside, 1/2, no, take out 1 over 25. So we take out 1 over 25, so that what is left here is going to be 5e to the 5x cosine 2x. I have a strong feeling that I should take out the e to the 5x, but let's just move on. And then this is going to be plus 2e to the 5x sine 2x. Okay, I think I'm taking this out now. So with this, we need to find what I is. So I is going to be, we divide both sides by 29 over 25, so that I will be equal to, I'm just going to multiply 25 over 29 times 1 over 25. And then I'm going to take out e to the 5x. Okay, finally, I did it. And this is going to be 5 cosine 2x plus 2 sine 2x. Okay, nicely done. So that I is going to be equal to, if you multiply this, you have 1 over 29 e to the 5x, 5 cosine 2x plus 2 sine 2x. And remember, our original problem was 2i, not just I. So we're going to bring back this 2 and say, therefore, the original integral, which is 2e to the 5x cosine 2x dx is equal to, now it means we're multiplying this by 2 since it's 2i. So if you multiply this by 2, you just put a 2 on top. That's 2 over 29 e to the 5x times 5 cosine 2x plus 2 sine 2x. This is what we've been looking for. Never stop learning. Those who stop learning have stopped living. Bye-bye.